Well, good morning, good afternoon, good evening to everyone somewhere in this lovely world, wherever you may be. Thanks for joining us live here today for Serverless Office Hours, streaming on the AWS Twitch channel, on YouTube/Serverless Land, and also on LinkedIn Live. My name's Julian Wood. I'm a developer advocate for serverless here at AWS. And today I'm super duper happy to be joined by Pallavi Srivastava. Pallavi, welcome to Serverless Office Hours. I know you are in northern and just in the northern part of Delhi, so it's like what 11:30 at night for you, so that is true dedication to teach us all about the cloud. So you're a senior cloud support engineer, and I honestly think that anyone who works in the sort of cloud support part must be a superhero, because you're in the sort of front face of getting customer calls, things are going right, things are going wrong, and giving advice. So yeah, tell us your journey. How did you come to AWS, and how did you land up in a cool role, and how come you're such a guru? That's cool.
Thank you so much, Julian, and I'm really excited to be here. I joined AWS as an associate almost 6 years back. It has been 6 years, actually more than 6 years now, being part of AWS support. My career started with AWS support, and truly it is always, as we say, right, day one at support, and even at Amazon. I get to learn something very different from our customers day in, day out, from my team, and it's great being here since last 6 years.
Oh, excellent. And what is your, I'm going to put you on the spot now, but what is your favorite service then in AWS if you have to pick one?
Um, yeah, I would say I'm a subject matter expert for API Gateway as well as Lambda.
Excellent.
I really love to work with these services. So I would say Lambda is definitely changing a lot of things out there. So I really like to work with Lambda. Yeah.
Perfect. Well, we have the right person on because we're going to be talking a lot about Lambda and API Gateway today.
Yeah.
So, proper cloud support engineer expert, not some of us who sometimes pretending. We'll be back with Pallavi in just a few moments while we look back over the past sort of few weeks of what's been going on Serverless Office Hours. Last week was a super interesting stream. It was all about using Terraform with AWS SAM to do local debugging and local testing. And Pranita and Mohammed did an excellent overview of it. And they did a really cool thing that I didn't even know how simple the debugging process was in SAM Local. Literally adding breakpoints. Mohammed set it up all live and showed us the whole thing. So Terraform is super popular. We absolutely love Terraform here at AWS, and now it just makes it a little bit easier when you're building your serverless applications that you can use the Terraform part, and the Terraform way that you can model your applications and you can deploy them. Oh, my words are going over. I'm trying to think of the term and it's escaped my head. Of the Terraform apply. That's of course it's Terraform apply. So Terraform apply, but then still use the SAM CLI to be able to do the local testing and debugging based on that Terraform template. So have a look. It's on the Serverless Land YouTube channel and looking at the previous episodes. What's new in AWS Serverless? I haven't got a lot of new things coming on. The one last week for Lambda was runtime management controls. This is basically for some advanced customers who don't want to always take advantage of that automatic updates, even though the automatic updates is one of the superpowers of Lambda. This just allows you to have a little bit more control. So if you've got some good CI/CD practices and DevOps things that you do, just allows you to have a little bit more control of when Lambda does roll out those updates if you need it. But generally, most customers won't need it. But if you need it, this one is going to be good for you. There's a complete blog post from Jonathan Tuliani, the product manager, explaining it. And just lots of other compute blogs. Look, s12d.com is our serverless land link shortener, and you can find out all things to do with AWS compute, including all the serverless things. But enough of last week. Let's talk about what we're going to be talking about today and preparing your serverless architectures for the big day. So, Pallavi, what do you consider a big day, and what would you like to tell us about doing some prep?
Yeah, so basically, we have worked with multiple customers, and we see day in, day out, customers are going live with their serverless architectures overall. And when we talk about the big day, it differs from customer to customer. But one thing is that they don't want anything wrong to happen on that day, truly, right? Because that's something where they're sending out their product to the customers, to their clients, and they want everything to go perfect. But at the same time, when we talk about serverless services, these are well managed services by AWS. So little management has to be done, as serverless itself says, right? Less management, more focus on the business logic. So customers have to focus more on the business logic, but at the same time, few things like limits, few managed things, how to secure, how to make sure that we are monitoring well throughout that day, so that we don't face any glitch during that streaming activity, during that live event which constitute of these serverless services. So I'm going to talk about majorly about API Gateway and Lambda, as these are the front end services which are directly integrated in the web applications. And whenever we are going live, these are the services which actually face the traffic, right? And how to prepare these services to make sure there are no issues in between, and you get like very without any interruptions, your services are delivered to your end customers. So that's what we are going to talk about.
Excellent. So, I mean, obviously, one of the big benefits of serverless architectures is they do scale down and they also scale up to crazy amounts. But your
Yeah,
whole thing is that, well, you need to do some preparation for that as well. It's not all magic. A lot of it's done for you, but there are some things
yeah,
you do want to make sure that you can scale up to as much as you need. I mean, I've seen a lot of applications where serverless scales to really ridiculous amounts. So don't think that there's this is only for scaling in a sort of medium way, not in a big way. This really can handle some really pretty big workloads. But like with all good architectures, some planning up front is always going to help. And also just
yeah.
remember we are live, so send us your questions and send us your comments. We have already from Twitch, Daniel Abib, hello from Brazil. Super happy to have you. Of course, our other AWS serverless hero, Zach Jones Noel from Bangalore in India. It's a little bit south
Oh,
of you, Pallavi, but we always have love having people from all over the world. We did have a comment from ddevlin07, also from Twitch. Terraform is yummy. It absolutely is. So Alpha Codes, you do have a question. I will get to that. It's about relational DBs. And of course, or close to home, I'm actually in England as well. So Main, Sale, Matt, thank you for joining us as well. So yeah, send us your questions and send us your comments, and we would love to hear them, or just tell us where you're from. It's also cool to find out where everybody. Oh, it's coming in thick and fast. We've got Christian from Paraguay. We've got somebody else from the UK. Delhi, another Delhi from India. So there we go.
oh,
The neighbors are watching. Excellent.
okay. So, just to get started with, what I'm going to talk about is majorly on the scaling part. First, like how serverless services are going to scale, what are the key considerations we need to remember. Then, about the performance tuning for Lambda and API Gateway. Testing is a common thing. Now, we all want to test and prepare our serverless services in advance to make sure we identify if there are any issues beforehand. So, I'm going to talk a few things about testing and how to prepare the services. And also, a very important and key part is monitoring and error handling with these services. So, let's get started. Just to give a heads up, serverless is just more than compute. It's not only Lambda, but we have many different serverless services. So I will take this opportunity to just put it out there that more than Lambda, API Gateway, there are other services which you can use as serverless. And together, all these services when combined together, create your serverless architecture and make them more robust. Let's look at this. This is a basic architecture where we have DynamoDB. So this is not a problem, right? We will know I have this API. Some amount of request would be coming, then it will go to Lambda, and then it will move on to DynamoDB. I know how to scale how much request is coming on this particular Lambda function. So till this point, no problem. But what if you have an API gateway, you have a client, and that API is talking to multiple different Lambda functions? Those Lambda functions are further talking to different downstream services like we have DynamoDB, we have SNS, or EC2 instances. Moreover, you know that Lambda functions can be associated with VPC settings. And then Lambda function can access resources in a VPC. So VPC resources are also involved here. So whenever we try to scale, at that time, we will also have to take care of those VPC resources. Now, let's say we have multiple API gateways. Now, the problem becomes more and more complex. So, in order to identify all of this, it's very important to make sure that we are preparing our architectures before any live event. And moving on around the scaling part, because this is the super important part. How to identify what is the estimated concurrency requirements for my Lambda functions. So just for the viewers out there, concurrency is not actually the request per second. It is actually at any particular instance how many Lambda functions are running. So we should never confuse ourselves with like, okay, this is concurrency and this is request per second, and both of them are very different. So it's very important for the customers to understand that we have to select the right concurrency value, and that is how we have to identify what are the limits we will require, because there are default limits for every account, and for different regions there are burst limit as well, which are very different. So everything matters: the region where your Lambda functions are hosted, the number of Lambda functions at any particular given time, which are active and receiving concurrent request. So let's say there are 10 or 15 Lambda functions you have in your account. You feel that, okay, this is one major Lambda functions which I have to take care of, but you also have to take care of other Lambda functions, because the concurrency is combined. It's a combined utilization of all the functions which you have in that particular region. So that's why it's important to identify in advance what is the concurrency value you require. And it's a very simple math. You just have to identify the average request per second and just multiply it with the duration, and you will get the concurrency requirements. Another important part with scaling of Lambda functions is, we know that Lambda can scale, right? Definitely, because that's the power of Lambda. But how much we want it to scale? What are the different capabilities we want? Do we want scaling limitations at per Lambda? Then we will go ahead with reserve concurrency. If we want our Lambda functions to be warm enough and they start accepting the request as soon as the request comes, then we need to use provision concurrency. So it's also important to understand what are the needs and decide whether you want provision concurrency or reserve concurrency. Another thing which is very important is the burst and the maximum account concurrency you have. Even if, let's say, you have raised your concurrency limits and you have raised it to 10,000, so still there is certain amount of burst request quota which is applied at different regions, and at any particular time the burst limit has to be valued and the burst is specific. So that's why we also have to take care of the burst limits which is associated with your Lambda functions. There is also a step scaling mechanism in Lambda, so that also has to be considered. So that's why we have to make sure that the requests which are coming are linear. We should not just give spiky traffic at once. So that's why all these things will come into picture when we talk more about how to test the functions, but that is around scaling, which is super important.
Pallavi, just
Another
before we go on
important,
to the VPC, when customers call in and they do have issues, what do you think is the thing they misunderstand the most, or have the biggest trouble with understanding
so the
for
biggest
concurrency?
Yeah, so biggest confusion is around the requests, the difference between the RPS, basically the request per second, and the concurrency. So concurrency is at any particular instant how many of the Lambda execution environments are running. Request per second is at any point how many requests is my Lambda service receiving, or my clients are sending in the request at this particular rate. Why duration is also important here, because the Lambda execution environments runs in parallel and no two execution environments are in contact with each other. So that's why the amount, if the duration is smaller, the execution environments can be reused, and then we can launch more execution environments. But we have to maintain and adhere to the concurrency value at any particular instant. So even if there are multiple and more amount of requests coming, but there are already execution environments running, we won't be able to serve the requests which are incoming. So that's
Okay,
why it's
perfect.
important to understand that.
Perfect. And just I've put a link to a blog post which somebody I know wrote.
Yeah.
It was me. So yeah, that's also has some nice graphics as well to explain what Pallavi is going through. But yeah, it's a common thing that we hear customers talking about. And I think once you understand it, you get it. And it's actually quite a simple concept, but it sometimes just needs a little bit of explanation, which will help you a long way.
Yeah. Okay, moving ahead, as I talked about function in VPC, right? When we involve one service with another, here Lambda function we associate it with VPC. That means Lambda gets the capabilities to connect to VPC resources after you associate it with the VPC subnet, security group, and other configurations. So, what Lambda uses is the ENI. So, ENIs are a VPC resource and it's being used. So, in case you are expecting a huge amount of traffic, you need to make sure that your ENI limits, which is 250 as of now, is actually adhered. Usually it's enough, but it totally depends from traffic to traffic which the customers are expecting. So, that is another limit which generally customers might miss, but it's important to note about those limits as well.
And do customers reach that limit when they've got too many security groups? Is that the issue? Because obviously, security group mappings match to the number of ENIs that are then
Yes.
created. Is that the sort of stumbling over where people come under? And then the recommendation is to rationalize those security groups.
Yeah, exactly. Because we use a new concept like hyperplane ANI is basically for Lambda when we associate it with VPC, and it is created as per the subnet plus security group mapping, the unique mapping. So based on that, we have to make sure that those mappings are correct, and if possible, so basically, if we have multiple functions, they are using the same VPC so that ANIs can be shared. But at the same time, it depends, right? Some customers would like to have multiple lambda functions within the same region, so that means they have multiple security groups for the usage. So that's why in some cases its limit can be increased. It's rare, but this is something which we have to take care of when we are launching something big.
Yeah, and obviously, if IP addresses can also be a fixed resource, so it's not as though you can just always magically expand the number of IP addresses you have. So yeah, a good
Yes.
limit to think of.
Okay. Moving ahead with API gateway a little bit. So in API gateway as well, there are limits, right? So the default limit is 10,000 RPS and the burst is 5,000. But in API gateway also, we have to make sure that this limit which is provided to us is actually shared between all the APIs: HTTP API, REST API, WebSocket API, the callback APIs of WebSocket. So that's why it's very important to understand that this APIs in general, we expect a heavy amount of load, right? And these limits are adjustable. So it's important to make sure that we calibrate our limits accordingly. And I'll just show a few things on the console as well where we can go ahead and request a limit increase. And it's always important to make an advanced judgment of how much limit, how much request we are expecting, and make the changes accordingly. At the same time, it's also important to verify the stage level and the method level throttling set, because we have also seen that, for example, let's say we know that for the overall stage we have certain amount of RPS set, but at this method level also we can set some throttling values. We could use usage plans, API keys. So there are different levels of throttling which we can set in API gateway. API gateway provides many different ways to control the number of requests your API is handling. So we have to make sure that we are checking all those limits set if we are expecting a high amount of requests for the big day. Also, when we're talking about scaling in API gateway, also whenever you reach out to the team or whenever you reach out to support to make sure that your limits are increased, it's important to verify what are the integration timeouts, because sometimes customers have do not changed the integration timeout, which is of 29 seconds. So the lower the integration timeout, the faster we use the token bucket algorithm, right? The faster your APIs will serve request. Even if it's failing, it will fail fast and send the response back. So it really helps to understand whether your APIs are able to handle the load and the number of traffic requests you are getting or not. Also, important thing in scaling is with specific to API gateway, we know that API gateway can be used in conjunction with custom authorizers, and those custom authorizers are Lambda. And this is a very common feature which is used widely in serverless architectures. We use custom authorizers. So when we use custom authorizers, not only API gateway limits, we also have to make sure that we adhere to the Lambda limits or the custom authorizer limits as well, because that is something where we have seen we raise the limits for API gateway, but for every request, the authorizer is also triggered, and we miss that, and that um, creates a lot of issues at the end. Also, scaling does not stop at the service which we are talking. These services like API gateway, Lambda, and other few serverless services talk to the backend services, so there are downstream services also included. So that is the reason we also have to make sure that the scaling is appropriate at the downstream level as well. API gateway will scale, but what will happen if the backend of API gateway does not scale? There will be a lot of errors, so we have to make sure around that as well.
So this can be something like a database or a third-party API. So you've sorted out your scaling for API gateway, you sorted out your scaling for Lambda, but then your third-party API has an issue, or you're talking to a database instance, which could be anywhere, could be on-prem, could be in the cloud, but can only handle a certain number of connections, and then you are sort of tripping over your background processes.
Yes, exactly. So, very simple, right? API gateway can have a Lambda function between SNS, SQS is it's still a queue, but um, do we know whether the backend of API gateway or Lambda function can handle this much traffic or not? Can they scale or not? So that's how overall we have to make sure that the scaling happens at every level. Otherwise, if even a one level fails, and these are synchronous connections in general, so if one fails, the whole basically the whole request workflow will fail and will cause errors. Okay, let me also show now few things, like for example service quotas. It is a very useful feature which you will see. You can just search for service quotas and you will see the service quotas dashboard. It is a service in AWS console. You can just go to AWS Lambda. There are multiple services available, and if you would like to see what is the current utilization you have, for me I don't have much traffic in my account. That's why utilization is low, and I'm also using a default quota value. I have not requested any limit increase yet. So that's why you see it here, but you will see what is the applied quota value. If you already have requested some limit increase, you can go ahead and check what is the value here, check the utilization. And if you want to request further increase, just click on the concurrent execution, select the particular tab, add the quota value which you want, and then request. So what it will do is it will create a request for you. It will also give you a support case link where you can share more details if the team requires it. And we have certain blocks as well which I'll share um with Julian, and we can add it there, which will help you to understand what all things are required when you request for a limit increase. And that's how you can. That's how easy it is to request for quota increases now using the service quota dashboard. Similar to Lambda, we have service quota dashboard which supports different services like API gateway, another services. We have SNS, SQS, so you can see all those as well. You will be able to see all the limits which exceed what is the current value or the previous limit increase which you have requested. So you will see all those things here, and it's very easy to request for limit increases using the service quota dashboard. And I will just recommend it to everyone, I think, to start using it, because it's a great way to just go ahead and connect to the team, and everything is available. You will also see utilization. You can see the quota request histories as well, if any of the quotas you have requested previously.
And I suppose it depends on the quota increase amount, how quickly that is sorted out. I know, some things can be done very quickly if it's a sort of within reason, and then obviously if you're going to be asking for hundreds and thousands of concurrency for something, you'll be able to have a chat with someone within the service team or support organization just to make sure basically that your application is being architected in the right way. Because obviously there's two things. One of it is to manage the service, and also there's a cost component to this. So we just want to make sure that you're building it in an efficient way as possible.
Yeah, exactly. There might be few things which will be asked if you are requesting a very high limit, but definitely there will be ways, there will be solutions provided. So it's just that these things have to be done in advance, not just on the day of the big day. So if you can do it in advance, you will get to know what is the right values for you. Overscaling is also not a good option. That creates a lot of threats, but scaling at the right amount and at the right time really helps by launching these big products.
And actually, just talking about the scaling, Alpha codes, yeah, good point. Still need to take into account the API gateway timeout, 29
Yeah.
seconds, not 30, when sitting in front of a Lambda function, which is 15 minutes. So, yeah, Alpha codes, you're 100% correct. Yeah, the fact that a Lambda function can run for 15 minutes, there's still an API gateway timeout limit of 29 seconds. So, this is only important for synchronous invocations, but yeah, you're right on the money there.
Yeah. Also, while scaling, there can be downstream service effect, as I said, right? If, for example, you have a Lambda function which is connected to Kinesis, you can get a certain kind of error. So it's also important that your downstream services are also scaled, and increasing limits using the service quota dashboard or directly reaching out to the support is the right way. Okay. Moving ahead with performance a little bit, to ensure good performance, we have to make sure that our functions are optimally designed, the code and the memory considerations are good, and that everything affects the Lambda duration. So one thing which you have to check during performance of Lambda is actually the duration, how much time your functions are taking, because duration, as we saw, directly impacts your concurrency as well. So Lambda duration is super important when we consider the performance of serverless stuff. Um, Important thing to note, function timeout is something which is a great capability provided by Lambda. Fail fast recover. For example, let's say there are certain APIs you're trying to reach from within your Lambda functions, and if those APIs are not reachable or there are any connection issues, if you have a smaller timeout set, your functions will fail fast, and then you can retry and then recover from that situation. But if you have a very higher timeout, if you have not taken care of the timeout, then there can be cases where your client who are actually making to Lambda request to Lambda will have to wait also a lot longer, and then they will receive the failure. So that's why we tell the strategy of failing fast, recover fast, do a lot of retries within your Lambda function, so that um, you can overall reduce the duration of that function and get the results faster. Similar with API gateway, major thing is latency and integration latency. We generally see the integration latency part as something which is how much time API gateway had to wait to get the response from the backend. So that's what integration latency is all about, and we have to make sure that we can use caching here. If possible, we can use the stage level caching, because caching will help us um, to will actually prevent like how many times you are going to the back end to fetch the result and coming back. So that's why we can utilize the caching feature of API gateway, but at the same time, while we are using caching feature, and if we're getting a huge amount of request, we have to make sure that we are using the enough cache size, because whenever we are talking about API gateway and we enable caching there, we see a cache size setting. So if we select the optimal setting, that means that there will be a huge number of requests which can be cached. Otherwise, the cache has to be flushed, and again, we have to cache the next request. So that eliminates kind of why we are using caching, right? So make sure that while you are using caching for API gateway, you use the optimal cache size as well. Very important, or I should say, a very useful tool for Lambda is Lambda power tuning. When we talk about performance, how it helps is it helps you to choose certain, or in advance the same code can be run with multiple memory, and you can see or estimate the cost as well as the execution time for that function. So the same function which will run with different kinds of memory settings, and we know that memory is directly proportional to the CPU power or the processing power we have for Lambda function and the execution environment. So that's why this performance tuning tool for Lambda actually really helps you to identify what is the right memory you should use. will help you to reduce the duration and will help you to further optimize your Lambda functions as well. So this is super important. I will really recommend, while you prepare your functions for the big day, you can try this out and make sure you use the available tools out there. And this will surely help you to reduce cost, as well as to identify the optimal memory which you can use.
And also, if you are using, you can now build Lambda functions on ARM-based Graviton processors, and Lambda Power Tuning also is able to compare before and after. So you could try switch your function to Graviton, could get faster CPU performance, and also it could be cheaper. So give that a go.
Yeah, be increasing performance and identifying the cost benefits at the same time. It's wonderful. Yeah. Another important aspect here is what kind of request we are sending, right? Whether it is a synchronous or asynchronous. So that's something which we have to decide. This is more on the architectural side, but I still wanted to put it out there because we see a direct difference, right? Whether we want to send acknowledgement to our customers first, who are actually connecting to our serverless services, or we want to serve the response then and there. That is a choice has to be made based on your performance. But we have those options. For example, API gateway can send to SQS or DynamoDB or even to Lambda, and then Lambda can also um, just pull these records from these pull event sources. So that's how you can design. And this is important to understand because the testing has to be done that way. You cannot wait for long if you have an asynchronous kind of request flow. But if you have synchronous request flow, you will have to use those kind of criteria for load testing as well during um, managing or trying to identify what is the right way for you. With this, we can move on to the serverless application testing. This is something which I want to point out because on the left hand side, you will see that in traditional approach we used to do a lot of unit testing, right? Then we move on to integration, and then we move on to end-to-end testing. But in serverless application, it's super important to focus more and more on the integration test. Now, what and how does it differ, right? Integration testing means, let's say we have an SQS and a Lambda function. Okay, if I test the Lambda function alone with sample inputs and see whether the code works or not, that comes under the unit testing. But if I want to see whether my Lambda is able to handle the load from SQS and is working properly at the same time and they are giving the right result, at that time we have to do integration test. And with serverless application, it's important to do integration test because you will understand the limits, you will understand how your functions are behaving, you will also understand what kind of logs you are receiving, what are the failure uh, you are getting. You can use SQS DLQs with Lambda functions or the destinations to identify how the flow works. So that's why integration testing is super important, as well as the end-to-end testing. And end-to-end testing, just to clarify, is, for example, you have a whole business logic, whole application. You're just testing your application for different business logics. That's what end-to-end means. So that's why in serverless the paradigm shifts a little, and we do more of integration testing. That really helps. And there are different ways you can do the test. You can test the functions or the APIs locally using SAM local. You can do automated test using the CI/CD pipeline or use step functions workflows. Just an example of step function workflow, you can create a workflow with a step which will test, uh, trigger a Lambda function with certain input and do the unit testing. That way you can have different states in the workflow which will do unit testing for different Lambda functions, and this can be done after doing certain changes every time with the Lambda, and that can help you to test the overall Lambda functionality.
So that is
But at the
actually
same
really cool,
time,
using step functions as your sort of testing workflow, because a lot of testing you
yeah,
need to do. Step functions is super powerful. Also, I think with the SDK integrations, specifically if you are reading and writing things, you can use step functions to write something somewhere, test that your Lambda function picks it up and sends it into a database, say Dynamo or something, and then you carry on using step functions SDK integration to check that that record has been added to Dynamo, and lots of other things. So that's a really good idea. Use step functions for your actual testing.
Yeah, and this is something unique, and this makes it easier also. I feel you just give the input. Let's say you make changes in the Lambda code, and you want some different kind of input to be sent to Lambda. Just change it in the step functions and perform the test for different functions at the same time. So it's really cool. At the same time, sending some emphasis on the load testing because it's super important. I think we can share some links and the blogs which are already out there related to load testing. Um, because load testing is important before you request service limits as well, because it helps you to understand what are the values you require, and will also help you to understand if any part of the downstream connections, any part of basically general integrations is failing. So that's how load testing really helps. Another point is around error handling. um, this I just combined all together, that failing fast and retry is super important, and the timeout values for both API gateway and Lambda is important, because as someone rightly pointed out, right, Lambda can run for 15 minutes, but your API gateway cannot. So even if your function is not giving any errors, API gateway automatically will error out and will send out the error response to the customers. At the same time, for handling those errors, it's you can utilize the API gateway customizations, where you can uh, change the response status code, error messages, and customize those in case of any runtime errors or any kind of timeout error occurs within API gateway due to the downstream. And you can make those changes to make sure the end user is not actually facing issues, or the application is facing issues. And if you want to create some kind of retry mechanism, you can do that as well. um, Another important thing is using destinations and DLQs for Lambda. I saw one question around, what if we are trying to test Lambda function and the SQS fails, right? If it fails, there are different ways to actually identify what the error was, whether it was due to visibility timeout, whether there was some size issues of the message, there was any error due to the message block which is coming, because there might be an issue with a particular message as well. So there can be different kinds of errors. So it's important to use destinations, and for async invocations of Lambda you can use DLQs as well. So these things really help you in advance. Even if you get any error or any kind of failures during that live event, you will be able to identify why that error occurred, and maybe you can try to find out um, later and make changes to your Lambda function code or your API gateway or any other service. So that's why you can try DLQs and destinations to make sure that you are getting the information around the failed request, and you can try to recover from it in the next time.
Excellent. Yeah,
Another important
Guru
thing.
name six. Sorry, Pallavi. Guru name six. Just to say, four. There are some. I can't find the blog post at the moment, but there's a blog post on working with SQS and Lambda, and that's got some really good information, because there are two things you actually want to do. One, you want to put a DLQ on the SQS queue. So if the message isn't processed and there's something wrong
Yeah.
with processing it from the SQS queue, you're not going to lose a message. It's going to go to the DLQ. But then, as Pallavi says, you can have a Lambda destination on the Lambda function, and because that is going to then catch errors in the Lambda function, it's not going to retain the message, but it's going to at least give you information about the message, which is then going to allow you to troubleshoot things. And then you still have the messages in your DLQ, so you can fix your Lambda function and reprocess them.
Just to address one more point, I saw that in case of fail fast, and when we're talking about timeout, API gateway will not actually retry in case, or retry automatically and trigger the Lambda function on its own, because it doesn't do that. So if you would like to retry, then you have to trigger your API gateway again, and then send basically API gateway will trigger your Lambda function again and will try to get the response. So it's not like the second time if you trigger the Lambda function and it works within 29 seconds, you will get the response. So it won't be the same request. Now the new request has to come up for that.
Yeah, so this is for asynchronous invocations. Lambda is going to try twice, and you can configure that. But yeah, Pallavi's talking about and Alpa codes. Yeah, thanks. This is behind API Gateway, and any synchronous request, it's then going to be up to the client to initiate that request again.
Yeah. So in that case, also we have to make sure that our clients it can be your application, it can be your end user. If it's directly making a call to API gateway, it will be their responsibility to retry basically. Okay. Also, controlling the dependency errors is super important, whether it's an API gateway or Lambda functions. There can be issues. For example, if you're using mapping templates in API gateway and you are using VTL for certain kind of input, but you receive some different input from the user, what will happen then? So there will be error that your API gateway was not able to transform the incoming data, right? So those kind of errors are actually kind of dependency error, because that depend upon the type of payload your API gateway is receiving. So that's why you have to make sure that you test your API with different kind of payloads as well to prevent any kind of issues there. Um, Another super important part of managing and keeping a check of the serverless applications during the big day is monitoring. Um, Major parts, we have CloudWatch metrics, the logs and the logs insights. We can use CloudWatch alarms, we can use CloudWatch dashboards and X-ray. All these together have to be used to make sure that uh, we identify the issues fast and make the required changes very easily. So Lambda Insights is a super powerful tool. You can just go to CloudWatch, see how your insights are set, and you just have to set that on the console. Maybe I can quickly show if I go to CloudWatch, and you will see here insights. Under this, you will see Lambda Insights. It gives you the power to visualize the performance on multifunction as well as a single function. If you have single function, you can choose the function for which you would like to see the metrics, and this is how you see. Or if it's multifunction, in case of big events, you can see multifunction, but in this case also you have to go ahead and ensure you have added enhanced monitoring in the Lambda function configuration. And once you do this, you will see all these metrics there, which are super helpful to understand how much invocations you are getting, what is the usage, are you getting any errors, if the concurrent executions are reaching, which particular function is taking more of the concurrent execution, whether that function is required or not. You can take that decision accordingly. And if one of the functions or two or three of the functions are causing exhaustion of the concurrency limit which you have, you can identify using these metrics, and also create dashboards, which are CloudWatch dashboards, and then request the limit increases accordingly. So these dashboards and logs are super important during the load testing and can really be helpful. For creating the dashboard, you just have to go to dashboard and create those. I just created this one dashboard where I added different metrics for Lambda. You can add Lambda, API Gateway, or other serverless services. So CloudWatch dashboards is something, um, a different utility, which I would say, which is very powerful and helps you to visualize data during your peak hours, and will really help you to identify if there are any failures happening.
Yeah, and just from Lambda Insights, what is the latency if you enable Lambda Insights on a Lambda function? I don't believe there is any much additional latency at all. The way this actually works is if you configure it on your Lambda function under enhanced monitoring, and it uses some of our functionality called Lambda extensions, and I think it's all asynchronous when it sends the information onto CloudWatch. So the response will go back to your client, and then the metrics, the additional metrics, will be then sent onto CloudWatch. There may be a slight additional cost implication because the Lambda Insights extension needs to run. I don't think it's much at all, but you are going to get a cool amount of additional information. For example, the memory usage and the network usage, which isn't available via the normal CloudWatch metrics. So definitely have a look at Lambda Insights.
Okay. Another good feature is Service Lens. I know that if you see this diagram, you can see that there are so many Lambda functions, but that's what a big architecture looks like, right? If you have serverless architectures, if you are using, and we have multiple components there can be multiple Lambda functions and a whole lot of different services. So what service lens helps you is to visualize your architecture and to identify which part and how the request is flowing, and this will help you in the longer run, and to visualize your architecture in general, and also to understand, okay, if the error is happening here, if it reaches this part, if this is the error message, which part of the architecture I have to go through and check. So this is another feature of CloudWatch, which you can use to visualize your architecture and can be helpful.
Pallavi, we have had a question which I suppose is related to this. When you look at service lens, and you think, oh, well, there's a lot going on here, what I can do, can we check the Lambda functions based on the tags?
I think we can. I have not verified it, but I can surely verify and check. But as far as I think we can check it
Yeah.
based on the tags.
Yeah, I'm pretty sure you can. There's an AWS service which you can either do tags or you can do CloudFormation stacks, and that automatically then adds all your resources, and it doesn't just need to be Lambda functions, can be a whole bunch of things to a particular service, and it's on the tip of my tongue and I can't remember it, but that's super useful because in things like Service Lens and in some other CloudWatch things and some of the cost reporting and in some of a whole bunch of services, it's able to bubble up a
service
single stack or an
catalog.
application.
Yeah, I think there are a few services.
I will find it. It's going to bug me. Resource manager, something like that.
Yeah, I think overall, what we are trying to say here is that these services are really for your benefits. And if you try to visualize your architecture using this, it becomes a lot easier to identify where the problem is, and we can go ahead and solve it, because visualization definitely helps, and it will help you to recover fast in case there are any failures at that time as well.
It's resource groups. That's what it is. So when you can use a resource group to organize your resources, and then a whole bunch of services like Service Lens. Thank you. You got me to Liquid or Surya. Thank you very much. Yeah, resource groups, and then it's easy to use. And you just on the drop down with things like Service Lens, you can just select your resource group.
Okay. Just moving ahead before we take some questions. So the key takeaways would be like, I'm adding a bit of security here, because when we increase our limits, when we make sure that our APIs, our services are up and running there for the big day, we should never or just lay low on security, because we are increasing the limits, we are keeping our APIs open for usage. So at the same time, we have to make sure that only the authenticated users which we want should have access, because with great limits comes great power as well, because there are a lot of API instances, a lot of Lambda functions which are going to run for that. So it's very important to maintain security there. Load testing, as I said, is super important. Even if you do a limit increase, you should know what kind of limits you require and whether you have done load testing or not. Our teams also try to check that and try to see whether overall you're able, your load or your architecture are able to handle that much load or not. Getting your limits increased early, super important. Do load test early, then you will get your limits increased early. You'll be well prepared before the big day. Monitoring, as I said, is super important, and it's actually the key to identify where exactly the failure happened and how to recover from it. And end-to-end testing, testing on different levels helps. And as I said, caching, right? Caching and using performance tuning measures for Lambda and for other services really helped in improving the performance. And visualization, as we saw, Service Lens, CloudWatch dashboards, X-rays are super helpful in identifying what exactly is the issue, and make sure that your architecture is fail safe for the big day.
Pallavi, that is excellent. A whole bunch of takeaways. Let me just do up some questions. Yeah, really appreciate you giving us a whole bunch of information. Mike Adam, thanks for joining us. SQS calls to Lambda are synchronous. What are the best ways to change these calls to asynchronous? I think there are two different things here which are maybe getting conflated. When you add a message to SQS, that is going to be synchronous, because you're going to send the message to SQS and you just get a notification from SQS saying message received. Then Lambda behind the scenes runs a poller, and that is going to asynchronously pull from that SQS queue, and then actually technically then synchronously invokes your Lambda function, but you don't really have any visibility of that. This is all behind the scenes and you don't sort of really care. So anytime you have SQS as a trigger to a Lambda function, think of that as an asynchronous process, even though the Lambda pollers are going to be invoking your function synchronously. And the reason for that is they need to then reply back to the SQL, talk back to the SQS queue to say, has the whole batch failed? Do I need to retry the batch or delete individual messages from the queue and proceed with the rest of the batch using the batch item failures settings? So think of SQS and Lambda as asynchronous, but ultimately the Lambda function invocation will be a synchronous one, but that's sort of details behind the scenes, which you probably don't need to know. But yes, send us another question, if you need more clarification. Pallavi, anything else you'd like to add?
Yeah, I just would like to say that there are just trying to see Lambda as three different types of invocation. One is synchronous, asynchronous, and the poll based. So this SQS comes in the poll based section, where you have an SQS or you have a Kinesis or you have a DynamoDB invocation event source. Basically, you do an event source mapping. You tell Lambda how many messages you want in the batch, which Lambda pulls, and then perform the operation and run the code. So that's how SQS is related to Lambda, and that's how the invocation happens. And I think all you already said, Julian. That's it.
Perfect. Yeah, and Mike, so does the synchronous invocation affect the performance?
No,
I would say
actually,
no,
like
yeah.
the if you're talking about the synchronous invocation of like, is it related to SQS, or should I answer in general?
No, I'll answer in
I'm
general.
not sure.
Yeah, as you were saying, I think there's no performance impact.
Yeah.
Also, if you're thinking of anything asynchronous, you shouldn't be as worried about the performance impact, because you haven't got a client that's waiting. So something like SQS, the whole point of SQS is to be able to put a buffer between whatever messages you're sending and the consumer being the Lambda function. So you haven't got a client that's waiting for those messages to be received. And so an asynchronous process lends itself very cleverly to all of this, because performance isn't as much of a consideration from the client perspective. Yes, performance of your Lambda function is important, but that's mainly due to cost and how many messages you can process at the same time. So that's where your performance impact is, but not a sort of client impacting thing. Alpha codes, yeah. Do you know any customers using relational databases with API Gate and Lambda? What are your recommendations besides switching to Dynamo to these customers when they run into issues such as exhausting connections?
Okay. I wouldn't talk about any specific customer, but in general, I would say yes. We have seen in general, customers are connecting Lambda specifically when they have their relational DBs in a particular VPC and they want to have secure connection. They put Lambda function, basically associate Lambda function with the VPC configuration and connect that. There are certain connection exhaustions which can happen, but I think it depends how you're initializing the connection. If you're doing it outside the handler, so in that case the connection can be reused. That's how you have to plan within your code how you're initializing the connection, because we know, right, if you initialize it outside the handler, it's reused, and whenever the execution environment is reused. So maybe I can share few of the articles related to that which can help you. But yeah, this is a common practice, which, and it totally depends from customer to customer what is the requirement. Switching to DynamoDB, definitely if you need DynamoDB, and DynamoDB has its own benefits overall.
Yeah. And also there's RDS proxy. So that is also a
Yeah.
relational database service proxy between, specifically built for Lambda functions and some
And
RDS databases.
yeah.
And that handles, so you have a single connection, which is highly scalable to RDS proxy, and then RDS proxy handles the connection to your database and also some of the security. So that's also another thing to look at.
Yeah.
And actually, just the last kind of thing, if you are stuck and you have a relational database that you can't scale anymore for whatever particular reason, then maybe it's time to look at something that's a bit more asynchronous. And you could, particularly if you're writing to the database, because reading with a database, you could have more read replicas, so you could solve that in other ways. But if you're writing to a database, maybe you want to put that message maybe on an SQSQ or something, and then asynchronously invoke from that SQSQ and with a limit of 100 or 200 concurrency. And so in time, that database will be updated. So it's another way you can do that. So does API Gateway. Yeah, Cloud Surfer, I had spotted this before. Don't think we've answered it, but yeah, when deploying Lambda to VPC, so as Pallavi has very correctly said numerous times, you are connecting the Lambda service to your VPC. You don't actually deploy the Lambda function in your VPC. There is a distinction which is important. Is it a best practice to deploy to dedicated private subnets? And is there an ideal size?
Yeah, it depends, like what are you trying to access from that Lambda function, right? And we have seen that, so in general, right, as Julian said, we always say that we are not putting Lambda in VPC. We are just associating a VPC configuration to Lambda. So that ENI which you get always have a private IP, and that is one of the IP which you get from the subnet and security group configuration which you have associated with. There won't be any ideal size as such, because the same ENI would be used to access all the resources of that subnet or the VPC configuration which you have associated with. So yes, the important thing to note is it will always get the private IP, and it's good to just associate it with the private subnet.
Excellent. Then Alpa Codes, this was another question. Is it recommended to use API Gateway as an anti-corruption layer to validate cache and transform requests? Only valid requests reach Lambda. And then what's so nice about Serverless Office Hours is I watch the comments and we have people answering each other's questions, which is even great. So you don't need to ask us. You can go from the wisdom of the crowd cloud. And so yeah, the MEM said yes, you can basically create a specification in API Gateway that will block requests immediately there. And so you're not using up any of that Lambda concurrency.
Yeah, and API Gateway provides different kinds of authentication mechanisms. You have like Cognito, IAM, resource policies, then Lambda authorizer as well. So you can use these kind of authentication mechanisms and features of API Gateway to limit your request. Not only for Lambda, I think for SQS, DynamoDB, S3, all these services can sit behind API Gateway, right? So you can limit, and that's the beauty of API, using API Gateway as a serverless service. You can filter the request, transform the request before sending it to the backend.
Excellent. Well, Pallavi, your knowledge has been incredible, and you've just been able to share so many good practices, tips and tricks and everything. So yeah, we really appreciate you coming on Serverless Office Hours. Before we do say goodbye, I just want to say the next stream next week is going to be visually design and build serverless applications. We're actually going to be looking at AWS App Composer, which was announced at reInvent last year. And this is a really cool way as a visual canvas. If you're visual people, like many people are, I am, then you can learn how to build your serverless applications that way. And then just quickly, never forget, on Serverless Land, if you're writing code or wanting to do things or integrations with infrastructure as code, we've got the serverless patterns collection, we've got the workflow collections for step functions, and the snippet collections for log insights, queries, and a whole bunch of integration tools and everything. And these are all on serverlessland.com, which has a handy new building event-driven architectures as part of it. And so yeah, one of your best resources out there for anything to do with serverless and building applications on AWS. So Pallavi, you've been amazing. Thank you so much for dropping all this awesome wisdom. It's been a pleasure to have you. We'll definitely have to have you back at Serverless Office Hours. But yeah, thanks for spending the time with us here today.
Thank you so much. It's good to. It was really good to be here, and I really loved how everyone is just helping each other and talking more and more about serverless. It's really nice to see.
Exactly. I love that whole part too, watching how everyone's helping themselves as well. So thank you so much, and we will see you next